to everyone. Today, on March Prahlad Yunjan Convention Forum Talk Program, myself is Ganga Paudel, a newly appointed EGS coordinator at Research Himalaya Foundation. Prahlad Yunjan Conservation Forum is a talk program organized by EGS coordinator with reliance to RHF. On this, today is World Wildlife Day. On this occasion of World Wildlife Day, with the theme Partnership for Wildlife Conservation, I'd like to wish everybody a happy Wildlife Day. So joining today as a guest speaker, we have Dr. Upama Ashish Koju ma'am. She is a senior researcher at Forest Action Nepal and is a visiting faculty in Kathmandu University in MSc Informatics. She has over more than 12 years of experience in the application of geographic information system and remote sensing, and she also has published more than about a dozen of articles in international and national journals. We are very glad to hear from you, Dr. Upama Ashish Koju ma'am. Now,
and thank you so much, Moini. Thank you so much, Resource Himalaya Foundation, for giving me this opportunity to share some of our research with and thank you everyone for being here to listen to my presentation. Shall I start sharing or?
Ma'am, before moving on, I'd like to request every participants and everyone to keep your microphone and audio and video off during the presentation. And I would like to remind you all that after presentation, we are having 15-minute discussion session. So if you have any questions or queries, you can drop on the chat box after that and after presentation session, and or you can raise your hand. Now, without further delay, I would like to hand over the platform to Miss Dr. Upama Ashish Koju ma'am. Over to you, ma'am. Thank you.
Thank you. Okay. I think I can't share my screen. It's disabled.
Okay, ma'am, now we can.
Ma'am, you're muted right now.
Okay. Once again, good afternoon all, and thank you for being here in my presentation and sharing. So today, actually, I'm going to talk about the biomass and its productivity estimation using the remote sensing techniques. Basically, the thing I'm presenting here is actually some part of the work of my PhD during 2015 to 2019. While going, okay, let me just share my screen. So actually, so today we will be mainly talking about two things. So one is that estimation of the forestable ground biomass using the optical remote sensing imageries. And actually this research, this portion of the research is kind of methodological research where we are trying to come up with the method to the more efficient method for in terms of efficiency, in terms of the cost, as well as the processing, and the method of biomass estimation using the remote sensing approaches. And then another one is more like kind of we can say the output-oriented research. So here we are, and in the second part, we will be talking about the net primary productivity estimation and the trend and all those things using the remote sensing approaches. So, actually, I think before going to the forest carbon, I think I can use both English and Nepali in mixed, yeah. So before going to carbon, we all know that why we do the land cover, land use, when we talk about the land use, land cover, and I think, can we just do auto admission, because it's come up, it's popping up every time. Let me just demise height. There, it's not here. I think it should be in the settings. Okay, whatever. So we already know that. So for forest mapping and also the land use, land cover mapping, to see how much is which area, yeah, and the change trend over time, we are very much using, and we are habitual. I think if most of you are from the environmental science or then forestry background, I guess probably you are, and then I think you are used to or you have studied already, or you have already, some of you have already used the remote sensing technique for the mapping of land use, land cover and forest cover with different imageries. So, and I think you have already, recently there was a kind of viral in our sector. I think there was a lot of sharing of the NASA land use forest cover chains from NASA. Actually, I just hide it over here. So they said like by 1993 to 2016, the forest has almost doubled, yeah. So they have like, so we have, it's the forest cover mapping or land use, land cover mapping with remote sensing approaches is becoming very much popular. And it's actually, I think it's very normal now. And also in case of the carbon biomass estimation, also it's very much common. So before going to the work, actually we will talk about why we need to estimate the biomass and its productivity. Yeah? I think all of you, it's just like a revision for you guys, probably, I know. So there is a climate change, there is a thing called carbon, and then forest and remote sensing. So why we need to, then from carbon, it's a biomass, yeah? So due to the anthropogenic activity, yeah, due to the population growth, it's triggering like a lot of, let me just, okay. So here, okay, it's triggering because there is a lot of anthropogenic activity and it's causing a lot of carbon emissions, yeah, that's causing the climate change, or that accelerating the climate change, temperature rise. So here, this is one of the, here is a carbon budget diagram of 2003 to 12. So there is a lot of carbon emissions, very high actually from the fossil fuels and the cements, yeah, and also due to the lot of land use, land cover change like deforestation, the major cause. And in other parts of the cycle, there is the carbon sinks, like the ocean sink and the forest sinks, yeah. So, and also, so of the biomass, 50%. So what is biomass? Why we need carbon, and why are we going to talk about the biomass is actually the biomass is the carbon sink that is, yeah. The forest is actually 90% of the forest. Forest is 90% of the total terrestrial biomass. So the scientists have actually found out that one of the means to minimize the carbon emission is protection of forest, or for the conserving the carbon, or developing carbon sinks through forest restoration activities and carbon saving the forest conversion to other, yeah, or like from deforestation and preventing from deforestation. So as we want to know how much is the forest cover. So similarly, kati carbon cha ta tyo forest ma bhanne kura, that's important to us as well. So like the forest cover mapping, remote sensing is also gaining much popularity for the continuous mapping of the biomass and the NPP. NPP is actually the about what is the biomass is actually kati cha ta, it's kind of weight, yeah. Aba kati cha forest ko weight per meter square per hectare in the forest, yeah. So NPP is per year or per day, or per decadal kati growth has, how much has the weight increase. So we can use the remote sensing technique more efficiently to estimate those things. Yeah. So today, as we talk already in the outline, so we'll be talking about the method-based research that we did, like for estimating biomass in a two-scale approach, and then the more output-oriented research on NPP for the 16-year periods from 2000 to 2015. So the slide is not moving. Okay, now it's moving. Okay. So our major objective, so we have two, as already told, we have already talked about these things. So we'll be talking about the development of two-scale estimation of forest above ground biomass, FAGB. Yeah. With the use of multi-resolution, we are actually using only the multiple optical imageries of multiple resolution. Actually, 3 types of imageries we are going to use in here. And Google, actually 2 optical imageries, and GVHR, actually Google Earth, very high resolution virtual plots. So they are also kind of imageries. So we are using those to come up with the forest biomass estimation, yeah. And another one is like we will be estimating and doing the trend analysis of NPP, net primary productivity in forest of Nepal. We are using the process-based model named Boreal Ecosystem Productivity Simulator, which is called BEPS model, to see the trend and estimations of daily, monthly, seasonal, and annual change trend of NPP over 2000 to 2015. Okay, again, it's not moving. Okay. Let's try this one. Okay, yeah. So this is the methodological chart. More surveys, I'll just describe it. So keys of first at local scale. So this is like using kind of key methodological based research, one of the part of my PhD. So what we did try to do is most of generally for developing country, if we need to have the forest sample, I think you guys have done the biomass sampling, yeah. The certain diameter area, you just take the DBH species informations and all, with the help of the remote sensing imageries, there are a lot of methods. This map of optical imageries, imageries, or you can use the LiDAR imageries also for height information. So we are using the optical imageries to whole area. If you case study imagine, we are working or modeling only in the Chiton district. So, but we don't have this all the sample points over the Chiton district. Only sample size. So what we are doing in this approach, or this methodological approach, is like water said, we just, which is the representative of that bigger area, we are just taking the sample plots, on the sample plots, using the allometric equation, we come up with the biomass, on the biomass, we are using that. So basically, I'm the key one is to biomass calculate about I think allometric equations and the way we come up with the biomass. Next slide, right? And then what we did, like we make this similar surrogate plots, surrogate plots or we also call them the virtual plots. And for that, we didn't, before we at the local scale, we have the biomass and crown, tree canopy cover, tree crown, we delineate of those samples using the very high resolution GUI imageries. I know. And we try to see the relation between those TCC, tree canopy cover, and forest above ground biomass. Yeah, but there are equation also, I know. The equation say what we did is like we developed the surrogate sample plots over whole district. So surrogate sample plots or virtual sample plots. We just generated the virtual sample plots randomly. Actually, stratified random sampling. Then this area we downloaded the GE plots, Google Art, very high resolution imageries, which is generally most of the time the quick imageries are there are a couple of softwares that can help us to download those very high resolution and georeference imageries from the Google Art Pro. So we use that on this using the object-based image analysis. We delineated this crown, crown delineated why, but we have this model. So fit the model with those information. I'm saying TCC, we have the equation for coming up with the FAGB. So we will get the forest above ground biomass for our virtual sample plots. On this, we use the Landsat imageries, usko matrices like the vegetation indices and different biophysical parameters are used to those predictor parameters, and the virtual plots FAGB, we use it to we use them in the data mining approach called MARS, the multivariate regression app model they call it. And we come up with the equation for estimating the biomass for the whole upscaled area. So this is kind of, and we were, and so when we estimated, after estimation, we had few of the validation plots, and also we tried to validate our results with those of the community forest, the measurements. So, and it was quite good. Okay, I think I will see it later. Quite good the result, accuracy we got it, yeah. So, our detailed steps are Alka. So this is the overall methodologies we were talking about. Okay, so Ambrosi, what we have in this approach is actually, so we developed a 2-scale first above ground biomass estimation method with the use of multi-resolution optical imageries and the Google Art virtual, very high resolution virtual plots, yeah. So the mapping, and so there are the 2 sub-methods in it, yeah, as you all can already see in the methodological chart, but I think it's, yeah, this one. So at the local scale and at the regional scale. So we are developing the equations, so mapping and estimation of tree crown, and then estimations of FAGB, yeah, at the local level with commercial GOI imageries, yeah. Then upscaling that information, using that information to upscale or estimate the biomass. I know we upscale the FAGB at regional scale with the use of the Google Earth very high resolution imageries in imageries virtual sample plots actually, and the Landsat imageries at the regional scale. Yeah. So it's upscaling. So we have the fields. So study area for this was actually in Chittor National Park. And here we did the same method for Nepal as well, but here we are presenting the case study of the Chittor. So we have like the sample plots, the actual sample plots from these water sets, yeah, and then we generated the relationship between the tree canopy cover and the biomass of those sample plots, and use it to come up with the biomass for the virtual plots that we created, the TCC that we generated, yeah. And then we use the Landsat imageries for the Mars data mining approach, and then we come up with that equation and use that for estimating the biomass for the whole region. The importance of this study was actually we were trying to develop more cost-efficient time efficient tool to use to come up with the biomass using the very high resolution imageries, because I think you guys knows it's really costly for going to field and sampling the biomass. That's why. So these are the main imageries that we use. So the GOI at the watershed level, which is 0.5 meter for the pan-sharpened bands, and then 2 meter for the multispectral RGB bands. So it's total 4 bands. Then we have for the virtual sample plot sites, we downloaded the 0.65 meter RGB composite QuickBird imageries from Google Earth Pro using Isile Smart GIS software. Actually, there are many other software also you can try your own. And then for upscaling, we use the Landsat imageries of different seasonal Landsat imageries covering the whole area. So firstly, at the local scale, so first task we need to do is we need to find out the relationship between the field actual sample biomass and the tree canopy cover. So we need to first use remote sensing to come up with the canopy covers. Yeah. So firstly, we use from the field, we have measured the species informations, the channel informations, and using the Sarma and Pukula equation, we come up with the first biomass. Yeah. Then in the image, the GOI image, we delineated the tree canopy cover using object-based image analysis. Actually, for here also, you can, there are many softwares to come up with object-based image analysis, but for here we use the eCognition developer. So this step is actually how we came up with the crowns of the trees using the OBAI. So just quickly, I'll just go through. So we have this filter imagery of GOI for certain location. Then we find out the brightness index. With the yellow brightness index, we find out the local maxima. Then we just do the region growing. So it's kind of like nearest neighborhood approach. So it just goes on expanding, with based on the similar brightness and NDVI informations. Actually, we need to make the rule sets in the eCognition developer, and we just go on growing the region group. Then we lastly, where there is the difference in those indices information, then the region is stopped there and the crown is generated. So this is the process of crown generations using the OBAI in the GOI imageries. So we have now the crowns. So this is actually not that important, but actually, so we have this total distributions of the crown in actually, this is not requirement actually in the whole watershed area, but for the sample areas. So the crown distributions was like most of the crown were of the size between 10 to 20 meters square. Yeah. And this is the validation of those delineations. It was quite good. So after we have the crown of those samples sites, as well as we have the biomass, then with the simple regression equation, we develop the regression equation. So this is Y means we have like FAGB equals to 1.086 times TCC minus this one. Yeah. So we have like with R square of 0.76, and this is the validation of it. So we have now from local scale, we have now the equation of the relation between the biomass and the tree canopy cover. So after that, using the Landsat imageries, we try to, because the Mars approach is kind of like multiple regressions, and to get a good representative output, we should have like the more the parameters that influence the output, the more it will be better. So these are actually based on the literature reviews and others. We found these predictor variables. So this is the Landsat bands from 2 to 7, because we were using Landsat 8, yeah, and then we have the biophysical parameters, expect them for steep and slopes, and we use the Tessel cap indices, the brightness, greenness, and wetness, and eventually the different vegetation indices like EVI, GBVI, NDVI, NDWI, SLAVI, and simple ratio. So we use these. So we have now the equations. So this part is on the Landsat imagery part, and we have now, I think, it's in the next slide, we'll be talking about, oh, sorry, I think I missed a slide. So here we have the equations. Then we have, we downloaded after that we downloaded the Google Earth. So we just will generate the virtual sample plots, virtual stratified virtual sample plots, we generated that, yeah. So हाम्रो इमेजमा यसमा छ नि. So we have the virtual sample plots. And two virtual sample plots, we delineate the crown, G crown, using the same equation, same method of OBAI. I know you algorithm use we develop the tree crown. No, tree crown go relation with biomass. We have that equation. So we use, and we have now the biomass for these virtual plots. What we did then next is like we use Mars approach, the multivariate adaptive regression approach, to come up with the equation that will estimate the biomass for entire at the regional scale. Yeah. So these are the parameters we use, or predictor variables we use in the equation, or in that data mining approach. So actually R was used for doing this Mars regression, Mars data mining approach. So this was the equation we come up with, and the SLAVI, green, NDVI, and the blue band brightness index. These were the parameters that were found to be important as a predictor variable in when we estimate the biomass at the regional scale or upscale scale. Right? So using that equation, because we have the continuous layers for all of those parameters, so we come up with the biomass at the upscaled area. So this is kind of like demo case study. We use the similar methodology to come up with the biomass for 2010 and 2015 for entire Nepal. Actually, this was the map we produced before, like the new map was made, so we don't have the tail over there. So this is actually, eventually, I think I haven't put this, yeah, okay, I haven't put the numerical value tables, but we found that as the forest cover, the biomass is also increasing, and generally the biomass ranges from this one, yeah, from 100, less than 100 to more than 400 ton per hectare. We calculated the biomass as ton per hectare, and this is like the change in biomass, spatial distribution of change in biomass. So 2000 to 2010, 2010 to 2015. So the blue parts are the one with more improvement in this 10 years period, the improvement in biomass, and the darker browner part are the one where there were degradations, or the biomass actually declined. Okay. Then we did the validation of our biomass with the observed. We actually, I think we have that in our, yeah, this one, yeah. So we have those the virtual sample plots, and also we have few of the wheel of found few of this sample plots that were measured actually in the field. So we tried to validate our result with those from the actual field biomass measured, and also in this part, and also from the watershed part board. And the result was, the validation was, satisfactory, like 0.78, 1.2. So this is the first part. So in our work, what we concluded based on our work or research, methodological research, is that this approach is actually convenient, scientifically sound, with a good acceptable accuracy. So it can be provided reliable biomass estimation, and which is cost efficient and easy to replicate with limited resources. So it is especially applicable in the areas that require multiple categories of information, and it is very much applicable for developing countries like us for RED+ monitoring and reporting. That was the first part, the methodological research part. And I think we can just go into the second part. So second part was the NPP, the net primary productivity. वर्षमा कति बढ्यो त weight हैन, weight of the forest or weight of the trees. So for that, as already mentioned, we use the process-based model called the BEPS, Boreal Ecosystem Simulator, and this is your BEPS model actually was in first January was primarily this model was generated in Canada and for the boreal forest. Eventually, there are many sub-models of this BEPS model that are useful in different topography. So Asia ko lagi, अनि त्यसपछि एसियामा पनि चाइना or in India को more forest type or match हुने, they have many modifications in the model, and so we use those one for the South Asian part. So this is the methodological chart, and generally I think you guys know process-based model, you need a lot of inputs. So it's very much input intensive. So these were the first part of the chart. These are the inputs we use in the model to come up with the NPP. Actually, the BEPS model, if we give the input of Delhi, we have the data, temperature, rainfall, climate parameters, forest parameters, soil parameters, and them and other LAI tree cover parameters, or you Delhi inputs or it will give you output of Delhi, our seasonal output, so seasonal input it will give you the seasonal output. So actually we try to come up with the Delhi, especially as a climate parameter, as we can, there are many sites, especially because remote sensing is quite good in the meteorological sites. So we have like daily and even hourly data for the climatic variables. So we use the daily inputs to come up with the daily outputs of the NPP. So here we have like the climate data we used where 2000 to 2000, as we were going to estimate the net primary productivity of 16 years period from 2000 to 2015. The climate data we used were the temperature, radiations, precipitation, snow depth, wind speed, etc., from which we got from the ECMWF. It's the weather data sites of ESA, and the data is quite good. And similarly, ESA on the other side, data, direct data, we use the annual forest cover informations from 2000 to 2015, and the vegetation type input also, and we got from DAC, it is a soil, we get the soil data from DAC, the field capacity and wilting point and dame, latitude, and the LAI and tree cover data were downloaded from the Moody's site. And then actually they don't have the daily data, but we use the interpolation technique to come up with the daily data of LAI. And then we had like a biomass, also the one we created by ourselves. And then the sample plus biomass. So we use all these inputs, feed it into the BEPS model, and come up with the daily NPP, which eventually we try to explore the trend over time. So these are the required inputs we put, and actually we have already here, so it's more in detailed form. So this is just some of the interesting trends that we found, just tried to show, because while we were exploring. So this is like, we have already done 16 years data of temperature, snow depth. This is one of the slides. Actually, we explore all the parameters. And here I have presented some of the interesting outcome that we saw, like here from 2000 to 2015. So here we have like the total temperature, the total here in every of the slides, we have the total is represented by the purple, total average of Nepal, I mean. And then the blue one for the mountain, green for the hills, and the yellow for the plain. So the temperature obviously will be the higher for the plain. And what we found interesting is like from 2000 to 2015 data, there was like the temperature from 2000 to 2000 was kind of like normal. Then the temperature has declined in the period from 2006 to 2011, almost 12. So it's kind of like there was a 6 years time period where we had the mean temperature kind of lower, yeah, then it suddenly increased. Then the mean temperature was increasing from 2012 onwards, yeah, and then similar the very much related relations was found in here in snow depth. So obviously when the temperature influence snow, yeah, snow depth. So there was good snow depth, especially I think when we talk about snow, so it's mountain. So in mountain, the temperature, of course, the temperature was -10, -8 or -7 range, but suddenly it increased actually here. The temperature, snow temperature, I mean, the temperature in the mountain increased up to -5, -4 or something in this period, yeah. And in the same period, the snow depth has very much profoundly declined. You can see this. This is really interesting. So we have like many glacier research, like the snow is due to the climate change and global warming, the snow is melting, the glaciers are melting. So it's also very much so like the snow or glaciers are very much so, mountain is actually fragile because of this reason, yeah. So another slide, it's not working again. This is the trend of dew point, and the trend of dew point is also kind of very much similar to dew point temperature, has shown the similar trend to that of the temperature. Yeah, so I think that's not that important. And this is the output. So we made the daily and all the different climatic parameters, the biophysical, the indices parameters to feed it into the BEPS model, and we come up with this. This is the visual representations, visual spatiotemporal representations of our NPP over time, and the annual NPP, mean average NPP. So here this is in the unit of like megaton per hectare per year. So it's the range from less than 5 megaton per hectare to more than 20 ton per hectare. Generally, we can see that the NPP, actually the weight change over time. Kati body to ek mahina, we do check ourselves also. So we are checking out on the forest, our forest, you know. So we can see that basically the NPP, even the forest biomass is less in the mountain, and the NPP, the productivity is also lesser, and then more higher at the higher plain side, and also some parts of the hills. And eventually it seems like, I think I haven't, because it was huge data, so I haven't put it, I think, in the numeric value in the slides. So this one, so after we had the 16-year NPP, we validate our data, our result with that of the mode, because we can also find Delhi annual NPP from the MODIS, which is 1 kilometer resolution. The NPP that we came up here with, because we were using is actually 60-meter resolution one, because we had used the Landsat, and also like different the climatic variables were high, like lesser resolutions one. So we aggregated and came up with the 60-meter resolution output of our NPP in our research. So we try to this BEPS, this one is our output, yeah, and the blue one, the dotted one are the output from the MODIS, and this is from the field validation. So from the biomass. So because we had biomass from our previous research, yeah, in Nepal, so we tried to just look at on it, and actually they are actually the relation between them is like the validation was quite good, and then there was certain difference in actually, this is kind of abnormality from the MODIS. Maybe there was something wrong in the MODIS data during that period. Generally, when because MODIS is a global level data, so they might have like very much representative samples from our country. That's why, and maybe they have some problem during that period that was either over their side, but in other years it was very nice, accurate information. Actually, our results were very much similar to that from these ones. So we further validated our data with जुन चाहिँ अब फिल्डमा गरेको हैन, फिल्ड डाटा दे हैव फिल्ड बायोमास डिफरेंट रिसर्च पेपरहरुमा कस्तो छ र हाम्रो बायोमास जुन हाम्रो नेट एनपीपी जुन हामीले चाहिँ द वन व्हिच वी हैव एस्टिमेटेड इज कतिको चाहिँ फरक छ हाम्रो र द वन दैट अदर रिसर्चर हैव डन भनेर हामी त्यो पनि हेर्यौ हैन. सो देयर आर लाइक वी हैव लाइक around 5 papers that we went through. You अगाडिको चाहिँ एनपीपी यो डाटाहरु चाहिँ the one that we have like in raster format भयो नि, यो चाहिँ हाम्रो डाटा from the paper चाहिँ हामीले हेर्दाखेरि like the Gautam and Mandal, यो चाहिँ सबट्रोपिकल ट्रोपिकल फरेस्ट सुनसरीमा चाहिँ गर्नुभएको रहेछ in 2005 to 14 मा हैन. उहाँहरुको चाहिँ फिल्डबाट ल्याएको डाटा they have NPP of 2.85 gram per meter square per day भने हाम्रो रिजल्ट त्यो एरियामा चाहिँ 2.35 आयो. So only difference was 0.5. Similarly, Thakur को पनि फिल्डमा गरेको डाटा ट्रोपिकल फरेस्टमा was only 0.3 gram per meter square per day मा चाहिँ फरक पाइयो हैन. यो एरिया चाहिँ कुन ठाउँमा ट्रोपिकल फरेस्ट अफ इन्डियाको चाहिँ घुमा रहेछ यो, which has similar to the plain region. So हाम्रो plain region सँग कम्पेयर गर्यो. Similarly, other researcherहरुसँग गरेर हेर्दाखेरि we have quite similar result to them. So we shows that using BEPS model, we can the using of BEPS model to estimate NPP is quite good method to follow, you know. So you other slides are just going on like costo छ त trend, what is the mean NPP per day per annum seasonal costo छ त्यो कुराहरु चाहिँ छ है फर्दर स्लाइड्सहरुमा चाहिँ. अझै डेली एनपीपी छ हाम्रो. डेली एनपीपी रेन्ज चाहिँ 0 to 0 त हुँदैन एक्चुअली, कुनै कुनैमा कहिलेकाहीँ 0 हुन्छ, तर ओभरअल एग्रिगेट गर्दाखेरि चाहिँ इट्स विल बी मोर देन 4.7 चाहिँ ग्राम पर मिटर स्क्वायर पर डे चाहिँ म्याक्सिमम. सो obviously there are more, the NPP per day is higher in the Rai region than in some of the part of the hills, lesser in the mountain. Yeah, this is the mean annual NPP. This one was the Delhi one. So range up to 4.7 gram per meter square per day. How many annual say it's from 0.1 to 3.5 kg per meter square, you know. And they thought I was obviously better saying NPP only more. And you say हाम्रो 16 वर्षको एग्रिगेट एभरेजिङ गरे हामीले जनरल ट्रेन्ड चाहिँ कस्तो छ हेर्नलाई ओभरअल एग्रिगेशन्स गर्यौं. सो एन्ड दिस इज पर स्क्वायर किलोमिटर्स चाहिँ अब सम अफ द पार्ट अफ द तराईको एनपीपीज आर रियली गुड कम्पेयर्ड टु अदर्स. Ani, obviously there is the vegetation is actually sparse, the forest is even sparse, so they have lesser NPPs in the mountain compared to the other parts of the country. So trend line or we try to look at, so over years the trend over average annual per day per meter square, you know, over 15-16 year period. So this is actually the average annual NPP trend per meter square. You say annual total NPP, total NPP. Yellow represents for whole Nepal, brown one for plain, hills ko green, blue for mountains. So total body generally of a mountain ko kamcha, त्यसपछि followed by plain को कम किनभने plain को forest area भन्दा forest area from के अरे हाम्रो mountain को बढी छ नि त हैन total मा गर्दाखेरि so they have like higher total NPP को कुरा भयो भने अब average annual NPP per gram per meter square per day मा चाहिँ हाम्रो we have like mountain is less so तर overall मा चाहिँ actually hill कै अझ राम्रो रहेछ यो plain को चाहिँ much higher छ अनि they have like दुईटा year मा कि here we can see like in the year of 2060 over the year of 2009 they have kind of like more higher productivity. Probably they have like more higher rainfall or something. We try to actually look at it. Key factor is this to what area is actually rainfall maybe data ma ke humara pani huna sakcha testo ekdam राम्रो यो सँग correlate चाहिँ गरेन हैन so हामीले त्यो slide राखेको छैन यो slide मा चाहिँ temperature मा चाहिँ actually यसमा चाहिँ यो जुन 2006 to 2019 तिरै they have like quite good temperature to certain case मा चाहिँ I think higher in temperature might be good for the good production धेरै बेसी चाहिँ हुनु भएन so obviously rainfall ले नि act गरेको हुनुपर्छ यहाँ but we couldn't find maybe data को के उले गर्दाखेरि चाहिँ पाइएन हैन but there was good correlation in the increase in productivity trend to the productive trend of the temperature and also the leaf area index यसको pattern they have like the pattern was quite matching. So LAI बढेपछि leaf area index बढेपछि obviously biomass बढ्ने नै भयो त्यही patterns are shows very good relations over them हैन so these were the things we found अनि अर्को चाहिँ हाम्रो spatiotemporal अब त्यसपछि LAI सँग हुन त राम्रै correlation छ हैन अब LAI सँग correlation राम्रो भएर पनि trend of the biomass sorry NPP को trend र the LAI को trend चाहिँ उस्तै छ हैन so cost कुन ठाउँमा चाहिँ धेरै राम्रो trend relation छ the correlation between the NPP and LAI area त्यो हामीले हैन so LAI को र जुन leaf area index बढ्ने बित्तिकै biomass चाहिँ overall मा बढ्ने चाहिँ obviously यहाँ चाहिँ तराईमा र ईस्टमा चाहिँ बढ्दै छ overall मा त्यस्तो धेरै drastically चाहिँ उ छैन correlation चाहिँ सबै ठाउँमा चाहिँ it's quite high like up to 0.89 सम्म चाहिँ आएको थियो त्यो भएन so this is the seasonal variation चाहिँ कस्तो छ because we have the daily data so some of with the seasonal one हैन per gram per meter square मा गर्दाखेरि generally we found that post monsoon को जुन productivity was higher highest actually among the all seasons and then the monsoons and winter or spring ma चाहिँ actually ठ्याक्क winter सकिने बित्तिकै भएर होला it wasn't that high use हाम्रो digital value numeric value मा हेर्दाखेरि यो whole नेपाल hill mountain and plain मा हुँदाखेरि चाहिँ spring मा भयो हैन अनि यो monsoon मा post monsoon and winter so we have like higher productivity during the monsoon period all like plain ma obviously has higher than compared to hills and then mountains and average भयो नेपालको त्यसपछि monsoon ma higher monsoon मा भन्दा नि winter मा यो ठ्याक्क पानी परेको केही समयपछि भयो नि त they have good monsoon season पछाडी चाहिँ productivity चाहिँ बढ्ने रहेछ हैन भन्ने अनि त्यसपछि monsoon spring मा आउँदासम्म अब पानीले धेरै इन्फ्लुएन्स गर्छ मनसुनले भनेर पनि देखिन्छ हैन so we have lesser productivity and another was variations you different type of forest भनौं न broadleaf forest र needleleaf forest मा चाहिँ generally obviously हामीले imagine गर्न generally चाहिँ अब यो जुन यो चाहिँ हाम्रो daily NPP per meter square र annual NPP per year भयो हैन so kind of like actually the NPP is in the broadleaf forest is almost double of the NPP of the needleleaf forest. Like here we can see like 0.9 जतिको छ overall अनि अझ बढ्दै गएको छ gradually the productivity चाहिँ average मा है यो average मा average annual मा चाहिँ बढ्दै गएको छ हैन gram per meter square per day भने हाम्रो यसको ठ्याक्क लगभग डबल हैन 1.7 के रे gram per meter square per day छ हाम्रो broadleaf forest को केसमा यो चाहिँ total भयो हैन gram per meter square per year चाहिँ हाम्रो almost 300 something मा त 600 something almost double नै देखिने रहेछ हैन So another one is this like different slope magic also NPP भन्दाखेरि generally lesser slope the lesser the slope त्यही भएर प्लेनमा obviously हुन त त्यो slope सँग चाहिँ different trees हरु कुन चाहिँ tree पाउने त्यसमा नि भर पर्ने भयो हैन त्यो इन्फ्लुएन्स गरे हुन्छ slope ले भनेपछि अनि जुन higher जति higher slope का छ the NPP is also lesser हैन त्यो देखाएको छ अनि these are the publications यो रिसर्चबाट भएको पब्लिकेसन्सहरु चाहिँ यो स्पेशली जुन यो मेथोडोलोजिकल एप्रोच टु स्केल एप्रोच र यो एनपीपी को यो पेपर्स वेयर आई एम द फर्स्ट अथर collaborator यो चाहिँ हाम्रो थेसिस भयो त्यो छ you can get those online and I'm co-authoring these of the papers and they are also related with biomass NPP things यति नै हो मेरो thank you so much for your attention would like to listen more from you about your queries. Stop sharing or say more. Okay. Thank you.
Thank you, ma'am. It was a very important talk. Now I would like to move on the discussion session. If anyone would like to ask queries, then raise hand by clicking the raise hand button or drop the question in the chat box. Thank you. In the chat box, one question has arised, ma'am, by Sheila Gimide. She has said that, can you explain some of the uncertainties that may arise while creating these types of models using remote sensing?
Yeah, thank you so much for very important questions, actually. That's right. Remote sensing approach, it's efficient because you can cover a larger area, but and especially when you use different models, and here we are using different models at different levels. So jati model use we have like integrations of error. In our thesis and paper, we have included those errors. What are we can use the error analysis method where we have already mentioned plus minus this much error. So we need to consider you average 80 ton per hectare by 80 gram of NPP plus minus we have included the error propagation. So we do need to consider that. Yeah. So jati धेरै मोडलहरु use गर्दै गयो error चाहिँ थपिदै जान्छ and we need to consider that.
Okay, thank you, ma'am. Next question arrived by Sumi Bhattrai. She says that what might be the reason for increasing NPP in the recent years, that is 2015-2014?
That's also an interesting question. Mainly, I think we need to relate the increase in NPP with the increase in, obviously, biomass increase. So we can look at if there is the increase in actually the land cover. So if the forest cover has increased, obviously the productivity in overall will have increased. Yeah.
Okay, thank you, ma'am. Now I am also quite interested in the topic. I would like to ask one query that you have said that you have evaluated NDVI and NDWI in your thesis or project, and what are the application of this using this NDVI and NDWI? I want to know, ma'am.
Okay, actually, we have in this like the second part and even the first part, both of the researches, we have used many of the indices, like we were talking about NDVI, NDWI, distal cap indices. So and many other indices also actually. So these indices actually are represented, like are very much related with the productivity. So हामीले generally मोडलमा के गर्छौं जुनले चाहिँ हाम्रो प्रेडिक्टर भेरिएबललाई चाहिँ हैन प्रेडिक्ट गर्न चाहिँ प्यारामिटरहरु जसले चाहिँ इन्फ्लुएन्स गर्छ त्यो प्यारामिटर युज गर्छौं. So त्यो जुन लिटरेचरहरु they have already proved that, like for example the water index, हैन. So water index mean in DWI mean the more succulency in the leaves. Yeah, त्यो आउने बित्तिकै त्यो बढी हुनुको कारणले गर्दा they will have like this stomatal performance र त्यसको चाहिँ बढी हुने बित्तिकै उनले चाहिँ will influence to the productivity. So त्यो युज गर्दाखेरि चाहिँ that will be one of the parameters that will be influencing the productivity of the biomass. त्यो सँगसँगै हाम्रो NDBI त obviously the greenness index, the more greener, the more stomata directly related. So these factors they are very much governing your biomass like influence गर्ने parameters for we use those indices.
Okay, thank you, ma'am. Now we have come to the end of the session. At last, I would like to request Dr. Gauri Shankar Bhandari, Research Fellow of Research Himalaya Foundation, to give a vote of thanks and conclude the session. Thank you.
Thank you, Ganga. Thank you, Dr. Kojo, for a wonderful presentation on measuring biomass and primary productivity with remote sensing technologies.
Thank you.
Thank you for accepting our invitation and presenting your research on this 118th series of PYCF. PYCF was initiated in 2012 in honor of Dr. Prahlad Yunjan, who founded Resources Himalaya Foundation. It is a platform for advocacy and knowledge sharing. As you shared your research outcome in today's series, it is conducted on first Friday of every month. In this series, we hold talks and discussions on the topics of public interest related to environment, biodiversity, livelihoods, and sustainable use of natural resources. I hope the participants of this 118th series are greatly benefited by listening to your talk. Thank you, Dr. Kojo. Over to you, Ganga.
Yes, thank you, sir. Now we have come to the end of our program of 118 series of PYCF, which is happening at the Zoom meeting. Thank you to every participant and thank you to Ma'am Upama Ashish Koju ma'am.
Thank you. Thank you, everyone. Yeah. Thank you.